All right, day 4 of curve sketching. We are developing an algorithm for curve sketching. So we're layering upon layer, and so what we've looked at so far are critical points. So our critical points is where our derivative is 0 or undefined. And that can tell us turning points or not, but it tells us great places of interest. As we look to the left of critical points and to the right, we can look at intervals of increase and decrease. We can find maximum and minimum values, and so on. We call this the first derivative test. And I would love for you to look at page 178, where they specify those things that I just talked about, and have a nice summary in your notes. We're going to continue with asymptotes. Woohoo! Right, let's look at the reciprocal function. We know what that looks like. And so the notation we're going to have a look at for a bit here is limits again. Don't cry. Don't cry. So I'm going to look at the limit as x approaches 0 from the right-hand side of the function. And as I get closer and closer to 0 from the right-hand side, I'm going that way, I get closer and closer to infinity. As I approach 0 from the left side, I am coming in from the left and I'm going, and I get closer and closer to negative infinity. As I go out to the right, so I go way, it's almost like we're traveling in math when we talk, isn't it? As I go out to infinity, so I'm going along this way, my y value is getting closer and closer, but never reaches 0. As I go left forever, I also get closer and closer to 0 from below. Let's just shift a little bit. If I have 1 over x minus 3, we know from our translations that I have a horizontal translation, 3 to the right, because horizontal is always crazy. So I have this thing going on, and my graph has shifted. And I know a lot of the same pieces are going on. As I approach 3 from the right, so I'm traveling this way, I am headed towards infinity. As I am traveling towards 3 from the left side, I am coming down to negative infinity. As I approach, I'm going to the right forever and ever and ever off the end of the smartboard here. I get closer and closer to 0, approaching from above. As I approach negative infinity, so headed out to the left forever, I get closer and closer to 0 from below. Third example. This one is a shift, again horizontal shift to the right 1. So we have a similar function. As I approach the value of 1 from the right, I approach infinity. As I approach 1 from the left, I approach negative infinity. And as I go to the right forever, I get closer and closer to 0. And again, to negative infinity, I get closer and closer to 0. Let's look at this one. So we're going to use our limits and our understanding of asymptotes. So for the first one, all right, let's look at this one. So if we're looking for a vertical asymptote, We know we're looking about 4 because we're looking for places where the denominator is 0. Okay. So I'm going to look at the limit as x approaches 4 from the right and the limit as x approaches 4 from the left. So we're pretending ignorance of what this thing looks like. X plus 3, x minus 4. So for the first, I'm going to use values that are getting closer to 4 from the right side. So I'm going to try in a calculator, I'm going to try 4.1, next value of 4.1, and then I'm going to try a value of 4.01. So for 4.1, I end up with 7.1 divided by 0.1. I get a y value of 71. Okay, for x equals 4.01, so I'm just that little bit closer. I have 4.01 and 3 divided by 0.01. I get 701. So with 2 examples only, as I approach 4 from the right, it appears that we are approaching infinity. As I approach from the left of my function, I am going to try values of 3.9 and 3.99. So when I put 3.9 in, I get 6.9 divided by negative 0.1. I get negative 69. When I put 3.99 in, I get negative 699. So with 2 examples only, it appears that we are approaching negative infinity as we come from the left. For my horizontal asymptotes, I am looking to x approaching infinity and x approaching negative infinity. Well, that's just a little bit trickier as x gets really, really big. X plus 3 and x minus 4 really don't have much distance between them. It looks like maybe it's getting closer and closer to 1, but this just doesn't seem like a super great method. It looks like as we approach, x approaches negative infinity plus 3 and negative infinity subtract 4 really are negligible. They really hardly have a difference. But this seems like a strange method. There must be a better way. So we think using these values that we're just kind of guessing at, and not too many at that, we think that as we approach 4, and as we approach infinity, we have these asymptotes. So yeah, not drawn on the scale. And it looks like we are approaching positive infinity as you come in this way, and perhaps approach 1, and approach negative infinity, and approach 1. All right, let's look at another one, see if we can get a little further. Y equals 1 over x squared plus x negative 6, which I could rewrite with my amazing factoring skills. X plus 3 subtract 2. Okay. So I want to look, oh, this could take a while, vertical asymptotes. I want to see where is the denominator 0. So I am going to look at the limit as my function approaches 3, negative 3 from the right side, where we're approaching negative 3 from the left side. I want to approach 2 from the right side and approach 2 from the left side. It might get painful. I'm not going to write that out every time. I'm going to call this f at x. Right. Using some values, I'm going to approach -3 from the right side. So -3.1, and then I'm going to look at -3.01. Sorry, those two are from the left side. -3.1, -3.01. And then from the right side, I'm going to look at -2.9, -2.99. What a painful process. Okay, let's see if we're getting closer in a positive direction or closer in a negative direction. So as we look from the right, I get -2.04. Get a little closer, -20.04. So with 2 examples, I think we're approaching negative infinity. As I look from the left side, I have a y value of 0.08, and then I have a y value of 19.9. So it's certainly getting larger in a hurry. We're just assuming that we're going to approach positive infinity. For 2, as we approach from the right, I'm going to look at 2.1 and then a little bit closer, 2.01. So these are important that you have the right order. So from the left side, this is where I have to think. 1.9, then a little closer, 1.99. Right? Correct. Okay. Right. 2.1 gives me a y value of 1.96. We go a little closer, 19.96. Looks like it's approaching infinity. From the left side, the y value of -0.233, and then get a little closer, -20.04 appears to be approaching negative infinity. Horizontal asymptote whoops. We are looking at the limit as x approaches infinity and the limit as x approaches negative infinity. And still to this point, we've got this just intuitive, what would be going on if x were huge? So we've got this function with 1 over huge. It would be so big. So if we had 1 over ginormous, it would be really close to 0. If we had 1 over ginormous squared and some more ginormous and it's negative and whatever, we would still get really close to 0. So we feel. So we're still a little loosey-goosey on the horizontal asymptotes, and we feel like there could be a better process. So let's see if we can play a little bit algebraically with this thing. We're going to factor out the variable with its highest degree. So this is counterintuitive of other things that we've done algebraically, but I'm going to factor out the largest power of x. So if I factor out an x squared, I would have 1 plus 4 over x plus 1 over x squared. Right, if I'm asking you to factor out the variable with the highest degree for the second one, it would also be an x squared. In our brackets, if I'm factoring that, it would be 3. Subtract 4 over x, so if I'm doing distributive law, I just check that I get what I started with. 5 over x squared gets me what I started with. That's going to help us with our limits. Here we go. Determine each of the following limits. So as we approach infinity, I'm asking you to factor out the variable with the highest degree. So that would leave me with the limit as x approaches infinity for, all right, let's factor out the x. 2 subtract 3 over x. And on the bottom, let's factor out an x, the largest degree. 1 plus 1 over x. Interestingly enough, the x's divide out, and I'm left with this interesting, the limit as x approaches infinity. As x gets really, really, really large, this fraction gets really, really, really small. 3 divided by huge gets really close to 0. Same with this one. So these fractions get very tiny, approach 0. So as x approaches infinity, those fractions approach 0, and we are left with 2 over 1. Let's look at this second example. Same idea. We're going to factor out the largest degree of the variable. Right, so x over, let's factor out the x squared, would be 1, and 1 over x squared. Okay. So what we end up dividing out is an x on the top and one of the x's on the bottom. As x gets really, really large, this fraction gets really, really tiny. Approaches 0. So we are left with really 1 over x because that fraction gets so tiny. And as x gets really, really big, this 1 over x gets really, really close to 0. The last one. The limit as x approaches infinity for 2x squared plus 3. Let's use this method. I'm going to factor out an x squared. I have 2 plus 3 over x squared. Factor out an x squared on the bottom. Cool. 3. Subtract x over x squared plus 4 over x squared. This is really 1 over x. All of these fractions, as x gets really, really large, approach 0. My x squared terms disappear. So as x approaches infinity, I approach 2/3. Well, I don't. The function does.